The rose just bursting into bloom, admired where'er 'tis seen, dispenses round a rich perfume, the garden's pride and queen. That welcoming verse was in the 2026 edition of the Old Farmer's Almanac, written by Susanna Rowson, a British-American author, stage actress, and educator who was born in 1762 in Portsmouth, England. She was the first woman geographer and an early supporter of female education. She died in Boston, Massachusetts in 1824. According to weather folklore, if on the 8th of June it rains, it foretells a wet harvest. And if it rains on June 27th, it will rain for 7 weeks. With many parts of North America experiencing drought conditions, it might be worth doing a rain dance on June 8th and June 27th to hedge our bets. To learn more about what the weather has in store for us, keep listening to hear our conversation with the Old Farmer's Almanac's meteorologist to learn how they make those long-range forecasts and to hear about the weather trends they're seeing and we're feeling. We call this podcast episode Weather Wisdom. Welcome to the Old Farmer's Almanac podcast. Today we have our second episode on weather wisdom. Featured guests include my colleague, I have senior editor Tim Goodwin with me, and then the OFA meteorologist, Brian Thompson and Chad Merrill. So again, welcome. And I'm going to let everybody just give a little intro of themselves and what they do. What maybe you do at the Almanac, Tim, and then we can have Brian and Chad talk about what they do as well.
Yeah, I mean, I'm not sure if we have enough time to talk about everything that I do, but
No.
I do a little bit of everything: fact checking, proofing. I write. Work on some editing. I work with Brian and Chad, on the weather quite a bit. They are super helpful to us to get these forecasts out each year. So, yeah.
Brian.
I'm Brian Thompson. I've been doing the Almanac for several years now. I think this is my fifth one. And outside of that, I do I've started in television, did some TV broadcasting for a while, local TV. And I've done some radio broadcasting. I've done some operational forecasting over the years, a little bit of everything.
How would you become a weather nut?
There's always a story, right? As far as I can remember, when I was young, I really enjoyed the weather. A lot of meteorologists have a storm or something specific that got them in. For me, growing up outside the Philadelphia area, it was the blizzard of '96. We had something like 28 inches of snow. Always loved the snow, and that was I think the storm, if there was one, that really got me into the weather. But really all throughout middle school, high school, I remember in high school I was starting to look at computer model forecasts and just really enjoyed it all the time growing up, and wanted to turn it into a career.
Now, just a question: now that you've gotten a little bit older, do you still love the snow as much?
Yes, I don't love the cold as much probably as I used to, but I still do enjoy the snow quite a bit, and I even enjoy shoveling it to an extent, as long as there's no ice.
You can come to my house anytime then.
Chad, tell us a little bit about what you do and how you got the weather bug.
Exactly. So I've been enjoying the weather ever since the blizzard of 1993. That's what really got me interested in weather. Now, back then there were only a couple of computer models. The internet was pretty relatively new, so I was watching the Weather Channel quite a bit, and the forecast models actually nailed that storm pretty well. So that got me interested. And then I also enjoyed the microclimates in Western Maryland because my parents live, that is, just east of the Allegheny Plateau. So once we get over west of the plateau, there was a lot more snow than Cumberland, Maryland. So the microclimates in Western Maryland intrigued me to want to study meteorology. And after college, I've been working in a combination of radio and the TV industry and doing some long-range forecasting.
Cool.
Now, we talked a little bit about what got you both interested in weather. What are some other wild, crazy, extreme weather events that you've been a part of, that you've experienced? Because, we've all kind of got those stories.
Yeah, I guess I don't have anything really extreme, weird. I've never seen a tornado in person. That's by choice. I'm not somebody that searches out a tornado. The one that always comes to mind, that always surprises people. I spent most of my childhood in the northeastern part of Pennsylvania, up in the mountains, northwest of the Poconos. And there was one storm. There was a snowstorm in April. The day before, it was 75 degrees, beautiful day. And then we wound up with 8 inches of snow that night into the next morning. It was one of the most extreme changes of weather I can remember even to this day. And it was a reminder that even though you can get a lot of false springs, and we've had a few of them across much of the country so far this spring, snow can still win out later in the year.
Yeah, I mean, for me, it was a snowstorm. I remember it was March 31st, 1997. I was watching the NCAA basketball championship, Arizona versus Kentucky, and it was just dumping snow. I think we ended up with 20 plus inches of snow. My mom was working as a nurse at night, so I had to go in the middle of the game, go shovel our driveway so she could go to work. So that like always stands out to me. And then you guys probably remember that ice storm we had up here in December of 2008. You know, at my house, it was fine. We didn't lose power. And then all of a sudden we had people calling us asking if we had power. We had people sleeping everywhere for like a week because nobody around us had power. Driving just to the office in Peterborough, you know, at my previous job, and you could just see the destruction. It was pretty crazy.
Yeah, some of those ice storms and those late season or even early season snowstorms where you have really heavy wet snow can be some of the most impactful just for the reason of power outages.
Yeah, and for me, it was the blizzard of 1993. I remember growing up and going outside and trying to clearing the snow off the car. And because it was so windy and the snow was so light and fluffy, as I tried to clear the snow off, it came back in my face and almost suffocated me. And I remember just being in awe that it's the middle of March in Maryland. We had this massive blizzard and all this snow is just coming into my face and I can't breathe. I have to go back inside. And besides that storm, I remember the back-to-back blizzards in 2009 and 2010. Those stand out. And then a major hailstorm that I remember in Hagerstown, Maryland, close to where my sister lives. It was just a massive hailstorm, which is unusual for the Mid-Atlantic in June. And I remember capturing footage of it. So those are the extreme weather events that stand out for me.
It's amazing how we do all have those stories.
Oh, we had a tornado here at our office in July of 2023.
And it came through and we all went to the basement, which was not a very good experience. And many trees at a school nearby us that are just a little bit up in elevation came down, sort of re-landscaped, shall we say, and just so lucky that nobody was hurt. And I have a tornado experience. I was working at UMass Amherst in the tallest academic library in the world. And it's not a place you really want to be in a tornado, even though they tell me, you know, it was built in a bomb-proof way. But the tornado of June 1, 2011, and it really wiped out about 500 homes in Springfield, Mass, further down the river. But we had to evacuate every student, everyone in the library. So there was thousands of us in the basement of the library, which was a very hot day. And I just remember it being kind of scary and hot. And then we were all released, but it had really done a lot of damage. And thankfully I think there was only like one related fatality in a very severe tornado. So in the end, at least not human destruction.
Yeah, it's a reminder that even though tornadoes generally aren't as common throughout much of the Northeast, there still have been some strong tornadoes. They can happen.
They can. And so
I covered an EF2 tornado in southern West Virginia when I worked at a TV station there. That was in 2024. That came through in the first week in April. And by the time the Weather Service got out there to survey the damage and we interviewed the National Weather Service meteorologist, giving his assessment, it was snowing. So we went from a tornado early in the week to snow later in the week, but that's just the climate of West Virginia.
Well, it's never a shortage of news in the weather business. And, you know, we've been in the weather business for a long time at the Almanac, as have you. and it's really been a backbone of the Almanac for many years. Even when our founder, Robert B. Thomas, started out and the Almanac was regional, he made weather indications at that time. He was an astronomer, and he believed that the magnetic storm cycles of the sun, those sunspot activity, which goes in the 11-year cycle, was really a big factor about and those patterns and that weather data and how we would predict just on hundreds of years of observation of those weather patterns. So that's kind of the weather, I guess we spend a lot of time talking with you guys because when the Almanac comes out every year, people are super excited to get the new forecast. We get a lot of calls beforehand, like especially brides and grooms wanting to get the perfect weather date for their nuptials. So, we, not just them, there's lots of other people that want the long range weather, but we spend a lot of time in the fall talking about the weather. And it's really important to a lot of people to just get some kind of indication. So we thought we'd love to ask you to explain a little bit about, we know lots of other factors come into play because we talk to you about it all the time, but for any listeners out there who are curious, hearing from Chad and Brian about how they do their work and making our long range forecasts.
Yeah, it's kind of a combination of things. I mean, you talked about the sunspot cycles. That's something we still use. We use various things, though. We use, of course, El Nino, La Nina. It's been one thing that's been key to the upcoming Almanac's forecast. There's been a lot of talk about a very strong El Nino developing that has big impacts for the weather as a whole. And there's a whole bunch of other oscillations, indices that we use. Chad can probably talk a little bit more about that.
Yeah, so we look at some large scale teleconnection patterns, the Pacific Decadal Oscillation, the Indian Dipole, the ENSO status, as you mentioned, Brian, El Nino, La Nina, quasi-biennial oscillation, and what the status of the polar vortex is going to be, especially during the winter and the early spring. And a lot of these variables are forecastable 12 to 14 months in advance. And when we put our meteorological skills together between the 2 and 3 of us that work on the Almanac here, we're able to come up with a forecast because each of these patterns produces unique weather patterns across the globe and especially across North America.
Yeah, and it's got to be kind of an interesting change for the both of you because, you spend, we always think of the weather, like what's going to happen today, what's going to happen tomorrow. People want to know, is it going to rain? Is it going to snow? But it's probably pretty fun to take this different approach and look at these really long range, sometimes we're looking at, 12, 16 months in advance. Tell us a little bit about, how you do that work and how you kind of take all of those pieces and put it together.
Well, we kind of start late in the year, kind of the year before the Almanac comes out. So it's probably around Thanksgiving or so. We start to look at things like Chad said, some of these indices, sunspot cycles, those are fairly forecastable 12 months plus out. Now, the El Nino we've been watching, we were still tweaking things even into the early part of the year, just because of there was some question just how strong it's going to get, still is. But that's been getting clearer as we've been going through the last several months. So we kind of start by putting together some of the seasonal forecasts, and then we kind of build the forecast from there. Kind of down to the daily forecasts and things like that. And this takes really the better part of the winter. We're working on it, and then really toward the end of the winter, early part of the spring, that's when the forecast is. We've pretty much finished all the zone forecasts, all the maps, the graphs that you see in the Almanac every year, and that's when it gets sent over to you guys.
And one thing that I'll add too is, we look at all these different oscillation patterns and these teleconnection patterns. And we also look at the recent climate trends. What are the 30-year climate trends, for example, across the United States during the summer, the winter, the spring, and the fall? And when we look back at when these oscillation cycles were, in a positive or negative phase, we do some massaging based on the current climate trends that we see across Canada and the US.
Yeah, because when we're looking back at patterns of teleconnections and those kind of things, we're looking at previous years' data, what happened in other years where things look similar. This is a very common long-range forecasting technique. But these days, when you're looking at data from the 70s, 80s, I mean, even the 90s, you do have to, as Chad said, you have to kind of massage it, maybe tweak what you're looking at, because what happened, we had some very cold winters in the 70s and 80s that just don't happen nearly as frequently now. So it gets trickier to use data that's older because we're in certainly a different kind of world of weather now.
Interesting. Could you just dig in a little bit? Yes. So this year we had kind of late breaking data because that El Nino, the model for that was really changing. And I'm just wondering if you could tell us a little bit about what you're seeing now, so that it might be stronger, and how does that impact? We talk about it all the time, but just to let people know what happens when El Nino kicks in.
Yeah, so I can comment on that a bit. So there's a lot of signs pointing to a strong El Nino this year. Of course, we do look at the forecast model trends. There is something called the spring predictability barrier, in which the forecast models can either overdo or underdo the ENSO phase for the upcoming fall and winter season. So that's something we pay attention to this time of the year. Once we get into January, February, March, and April. However, the signs are there in the Pacific. First of all, there were 2 typhoons rotating back to back, one in the northern hemisphere and one in the southern hemisphere in the Pacific. And that has sent Kelvin waves across the Pacific. So Kelvin wave helps to bring the warm water from the West Pacific into the East Pacific. And we've been watching not only the Kelvin waves from those particular twin storms, but we've seen them come in through the late winter and the early spring. And that's a precursor to a developing El Nino. So what's going on with the weather patterns and the push of the Kelvin waves across the Pacific Ocean is giving us the clues that, yes, the forecast models are showing a super El Nino, and we're seeing the precursors already. So we have very high confidence that we are going to enter an El Nino, and likely a moderate to a very strong El Nino by this fall.
Thanks. That's good, because you hear those terms thrown around a lot, but a lot of people don't know what they mean. So it's kind of interesting to hear kind of the science and the gathering of information behind it. When it comes to long range forecasts, why is it so important to some people, specifically when it comes to like growers and farmers, like who else is, do you find that are particularly kind of interested in long range forecasts?
Well, I think it's like you said, it's people that are planning things way ahead of time. People that are looking for weddings or something like that. That's long. That's a long range out. You're grasping for anything that gives you guidance as to what to plan
And confidence.
And of course, climatology helps. In parts of the country, it's colder in the fall versus other parts of the country. But I think that's just such a key factor. And for people that are growing things, you're talking about frost dates, early frost, late frost, where there's a freeze. Those kind of things are really important. And really rainfall, I think, probably one of the bigger things. We have a lot of drought and dry weather across a lot of the country now. So it's just so crucial to farming and growing things, even if you're just growing a tomato plant in your backyard.
And confidence.
Yeah. And actually expanding upon that a bit, yes, it's definitely important to the gardeners and the farmers. Looking at the almanac, they want to see the trends. Is there going to be a late freeze? Are we going to have a warm winter and then a late freeze? To them, that means that my fruit trees are going to come and start to bud, and then we're going to get whiplashed with this cold weather, so that I might have to plan, extra irrigation out ahead of this frost that's going to happen, let's say in the middle of April. I also think that recreation enthusiasts are probably interested in the Almanac's forecast because take, for example, southern West Virginia, the New River Gorge National Park. A lot of people do whitewater rafting in that particular area. Well, if we're expecting a very wet summer, those waters are going to be very choppy. But if we're expecting a very dry summer, there might be limitations to kayaking and whitewater rafting. So there's a lot of recreational users who might be interested in the forecast and the almanac, especially different waterways. Also, water suppliers. Colorado River right now is very low. The Mid-Atlantic suffering from a mammoth drought as well. So these folks probably want to know what the water budget looks like for the upcoming year.
Absolutely. And we've talked about these trends, like you said, not just looking at the sunspot science, but also, these other indicators that we need to look at. And we've discussed this before, but I'd like to hear, we just mentioned a few of the challenges of long range forecasting. One of the big ones that comes to mind for me is microclimates, how we were just saying that those exist. And so obviously I know that's a challenge, but from your perspective, what are some of the things that keep you up at night?
Yeah, microclimates are certainly one of them. And I know we've discussed some of these before. I know Tim and I have discussed the California zone in particular can be a real a bear because you've got some huge elevation changes throughout the state of California, which causes all sorts of different weather. It's a state that can see very volatile weather one way or the other, whether it's very dry weather or very wet weather as well. And there's simply a lot of challenges just from how things can change. There have been times we've thought we were going into an El Nino, and then it stays a La Nina that happened a few years ago when the teleconnections didn't shift as quickly as we expected. And there's just an inherent unpredictability to the weather that always exists, and
You don't
we
say.
see that, of course, in the short. We see that in the short range. And we see that especially in the longer range because when you're looking at computer model forecasts that go out an extended period of time, if the model is assuming something in the short term that is incorrect, that error just gets exacerbated later on throughout the forecast period.
Yeah, and also speaking of microclimates, one particular microclimate that folks in California might be concerned about is, the marine layer. Typically you get this thing called June gloom where you get a lot of low clouds in June and very limited amounts of sunshine. Well, sometimes that can be dictated by the water temperatures off the coast of California. If they're very warm, you might have limited amounts of cloud cover in June or low clouds. But if the waters are really cool, you can get this particular oscillation pattern set up where there's a lot of low clouds. And sometimes, that warm water off the coast can actually help to ignite thunderstorms in a typical dry season in California, places like Los Angeles and San Diego. So, understanding the weather patterns off the West Coast can help to predict whether there's going to be either an excess of days with low cloudiness or more thunderstorms than normal in the summer, perhaps more tropical moisture coming up late in the summer and early in the fall, or a particularly dry summer, and how does that factor into the fall and the winter water budget?
You know, we talked about challenges, and we know that there's challenges with everything, but obviously, well, I don't want to say obviously, but there's got to be some ways that you guys have seen in your careers how long range and short range forecasting has improved and things. So, what if things have improved over the years? What kind of data or technology has allowed you to kind of put these together, with a little bit more ease or a little bit more confidence?
Yeah, especially in the short range, we have so many more tools than we did even when I started, 20 plus years ago. We had a pretty sizable array of computer modeling back then, but there's more computer models now, and I think most importantly, they're a higher resolution. A lot of these can give us at least an idea of where thunderstorms are going to develop on a given day. Not perfect, of course, but a big improvement from where we were 10 or 20 years ago. And there's more and more of these models coming online. So we get a better, it help us get a better picture of what the environment looks like. And that's why we've seen weather forecasts, especially in the shorter range, become more accurate over recent years.
Yeah, and also expanding upon that, there is a lot of reanalysis data that's available from the past, like from 1949, 1950, all the way up to 2025. So when we get together and we look at these teleconnection patterns and we look at past years that are similar, this reanalysis data helps us to kind of put things in perspective of how the weather pattern is going to develop across Canada and the United States, and getting that visual representation based on this available data from the past that we didn't have 5 or 10 years ago helps to kind of model the forecast for the next 6 to 12 months.
Yeah, and to kind of go deeper into that, we've seen just in the last couple of years, as has been the case in a lot of places, a lot of the we're starting to see computer models and AI computer models that kind of some system learning uh, ideas here, where you kind of ingest some of that older data and you try to see if the computer model can kind of learn over time and see if that's a better see if that produces a better outcome than the traditional computer models we've used for many years.
Yes, that's a very good point.
That's so interesting. I think we talk a lot about this when we prepare for our interviews, and we talk about trends, and that's kind of it's what you're saying too. Is maybe you can use models that are using information that is more recent too. Like if they can tweak, okay, you've got this large data set, but we know there's this climate, factor in. So when we've talked about these trends, things like seeing rainstorms that are more are unloading more water in a single storm or a short amount of time is a trend that we hear about. I hear about all the time when I talk with people all over the country. We've talked about drought, but also this idea of cold shots kind of coming down further south than ever before or for a long time. And growers, I just talked to people in New York this morning, and they got hit with a late frost in their particular area in Warwick, and there go the buds on the apple trees. So we know some of those trends are happening. So can you tell us a little bit about those and some of the factors in those trends that we say maybe are more recent?
Yeah, we have seen many instances where you get dumped on with heavy rain and then it's dry for an extended period of time. Um, that was the case when we were doing some research with the summer outlook, looking at past years that look similar to this coming summer. 1997, 1998 was the super El Nino pattern. And during that particular summer, there were instances where you get these clusters of very heavy rain over a short period of time, over a short distance. So you get one particular area, maybe of a state, that gets dumped on with rain, but the rest of the state is relatively dry over an extended period of time. So we're seeing these large fluctuations in precipitation over a short distance, particularly in the summertime, with these thunderstorm complexes that develop. El Nino is a prime example of a particular pattern in which this does happen. But rain is less uniform, especially during the summertime, but especially during the El Nino phases as well. And in a potential contributing factor, besides the ocean temperatures, can be Great Lakes water temperatures or river temperatures, etc. Also, we have more urban heat islands than we have in the past, and that contributes to significant amounts of heat energy going up into the atmosphere, and you need heat energy for thunderstorms. So there's been obviously a lot of urban development, especially in parts of the east, that might have contributed to some of these precipitation fluctuations as well. Also, I did read a recent study that talked about how wind turbines in Oklahoma can contribute to some microclimates. When thunderstorms pass over the wind turbines, they tend to intensify a little bit and you get a little bit more lightning. So I think there's some things that are happening across, on the earth that are helping to alter some of the weather patterns that we see for sure.
Yeah, and temperature, just looking at temperatures, like you were talking about the late frosts and hurting buds, it seems like we get these warm ups that happen a little earlier in the spring, and then things start blooming. But we still have chilly spells that last into May, and that can lead to these late frosts. And now it's not that the weather is warmer everywhere every month of the year. We have noticed some patterns that we do use when we're kind of putting together the almanac forecasts. We've noticed across much of the U.S. and even much of Canada that that summer tends to hang on a little longer into the fall. And it just anecdotally speaking, living in the Northeast, it feels like fall foliage is a little more. The seasons can be a little more hit or miss, or can vary a little more, and some of that has to do with trees getting stressed due to drought conditions throughout the year, and also if it's warm and wet deeper into the fall, that can sort of delay things as far as fall foliage goes as well. But on the flip side, we've noticed this happened. We have these normal sets of temperatures. You hear normal, average, high temperatures. These are 30-year data sets. The current one we're using spans from 1991 to 2020. And if we compared this normal set to the last one from 1981 to 2010, in a lot of the spring months in places like the Great Lakes, the upper Midwest, south central parts of Canada, the winter actually hangs on a little longer. It's kind of a winter hangover into the spring, where you have the cooler weather kind of lingering longer. So it's not just a one size fits all. But the other thing that we've seen, and this is something we have to consider when we put together a forecast, especially in the wintertime, is that even though we have cold spells, we have cold months, we had plenty in the east this past winter, it is very difficult. Our winter in the almanac is 5 months long. It's very difficult to get 5 months of colder than average weather. It's been the case for the last at least the last several years. We did have a good chunk of the east that did wind up below average for temperatures this past winter. But even last winter comes not this past winter, the winter before, the winter of let's see, it'll be 24, 25. That comes to mind because we had, if you recall, we had some cold weather that winter, especially during December, January, and February. But November and March wound up so warm, it overwhelmed a lot of the cold in the country. So that's something we have to weigh when we're putting together these forecasts, because it can be very difficult to get 5 months of overall cold weather.
Yeah, and expanding upon what Brian was just saying, part of that reasoning is because of another factor that we follow, the polar vortex. The polar vortex has done some unusual things over the past couple of years, and usually it goes through one final warming event in the spring. And when it does, like it did in 2026, and it did last year as well, you get these cold outbreaks that bring colder weather farther south, and it makes winter's tail seem a lot longer, even though you get those warmer spells in February, March, and parts of April. So that's one thing that we do follow as well, is the polar vortex. And there is some research out there that talks about if the polar vortex will be strong or weak based on some other teleconnection patterns that we look at, such as the quasi-biennial oscillations. So we factor that into the forecast whenever we do it.
Fascinating.
It is.
Glad you're here to explain that so we don't have to.
No, but it's really, we feel those patterns and we feel the outcome, obviously. So it's so interesting to understand more about what's at work.
Yeah. Now, you guys have mentioned this a couple times as we've been talking about drought. Obviously, much of the country has experienced it over the last couple of years. Many places are experiencing it now. What are some of the various factors that are kind of influencing that kind of drought in certain areas, or the widespread drought in many places?
Well, first of all, I'll talk about the Southeast, and I think Brian can probably touch base on the West a bit. So last year, we're talking 2025, the hurricane season was fairly muted. There was very little in the way of impacts across the East. And in the southeastern part of the United States, much of their precipitation, their rainfall in the late summer into the fall does come from tropical storms. Not saying that every year there's a tropical storm that hits Georgia or Florida, but at some point, tropical moisture gets sucked into the Southeast. And this past year, they missed out on a lot of that tropical moisture. So what that did was that created a fairly dry environment. We had a winter where we were transitioning from a La Nina into an El Nino. And typically, when that happens, you get a strong polar jet stream that brings some colder air farther south. But without a subtropical jet stream in place, you don't get those southern storms. So the southeast going into the winter was drier than average. And then we had a dry winter on top of that. So what that did was that dried out the soils quite a bit. And then once we emerged into spring, now in the southeast, of course, spring starts a little bit earlier. You get the increased evaporation. So the drought expanded pretty quickly. Another factor that we look at is the salinity of the Atlantic Ocean. And some of the salinity values that we saw matched up with patterns that would bring the Mississippi Valley quite a bit of rain in the Midwest, but the Southeast fairly dry. So what happened was a combination of a dry fall, a dry winter, and a dry early spring created this massive drought across the Southeast and part of the Mid-Atlantic, and that's why it's been fairly dry. And one pattern that typically cycles through a bit and brings drier than average weather is La Nina. We've had more La Ninas than El Ninos over the last 20 years, and that's why we've seen a good bit of drought, at least across parts of the East.
Yeah, and that has a big impact on the West too. And of course, there was no secret this winter that it was very as cold as it was at times in the eastern part of the country, a part of the U.S. The Western U.S., many states, it was the warmest winter on record, and there just really wasn't much snow, and that was really a huge contributor to the drought that's going on right now, because of the kind of the persistent cold. And what was really driving that was there was a persistent trough. We talk about the jet stream a lot. There was a persistent trough in the jet stream in the eastern part of the country and a ridge across much of the West. And when you have that ridge in place, that kind of keeps the storminess farther north. Places like the Southwest, and these are areas that rely on these winter storms because there's a good chunk of the late spring, summer, early fall. There's very little rain in a lot of these areas, so you really rely on that snow, that rain, to get through those drier times. And there's just so much drought right now, and some very severe drought through the Rockies, into the northern into parts of the Northwest as well, especially eastern parts of Washington, into Oregon as well. Kind of the interesting thing is it wasn't a really wet winter in California, but it was wet enough to keep a lot of the reservoirs actually above average, or where they typically are this time of year. So California actually is one of the places that we don't have a lot of drought. And in the last, as Chad was talking about, really the last 20, 25 years, California's been a frequent kind of magnet for drought, especially when we get into these La Nina patterns. But this year it was centered, the drought has been centered farther east because there just really hasn't been that snowpack. Again, the ski resorts were struggling throughout the winter, and even in California, because it just really wasn't cold in the mountains a lot of times when that snow came through, and the snow was melting really quickly when we had that March heat wave come through. So there's just a lot of factors that have contributed to that drought that's developed across the West.
Wow. When you're looking at, long range weather forecasting, are you seeing any patterns that you're watching that could indicate maybe how we'll get some relief from some of this drought in certain areas that you talked about in the coming years or coming cycles?
Yeah, so it does look like El Nino does benefit the West quite a bit with moisture. So those areas will likely start to see some precipitation. It should start this summer and likely continue through the winter. In the East, it can be pretty variable once you get into the summer. A very strong El Nino tends to shear apart Atlantic hurricanes, which provides a lot of moisture for the Southeast. But on the other hand, other weather patterns that develop with the subtropical jet stream being enhanced and maybe a ridge weakening across parts of the West that helps bring moisture into the East later in the summer. So when we look back at past El Ninos and past La Ninas, each one is relatively unique in what it does. But for the most part, El Nino helps with moisture, helps replenish moisture. And La Nina leads to a lot of dryness, except for parts of the northwestern U.S. La Nina can be pretty beneficial with moisture with the active polar jet stream. However, in El Nino situations, you get a strong subtropical jet stream and that dries out parts of the Northwest and Canada, but it leads to more precipitation or rainfall in California, Arizona, and Colorado.
Yeah, one of to kind of build on that to the how La Nina kind of breeds this drier weather. The one thing I was kind of struck with when I was going through our forecast from last winter's this past winter's almanac was in the month of December, especially. There were places in really every zone in the U.S. and I think a good chunk of Canada that were below average precipitation wise. And usually there's at least a few places where you have widespread wetness and snow in the case of December. But we had some really dry stretches across large swaths of North America this past winter. So that has not helped things over the last several months.
Also, when you get a drought of this magnitude, what can happen is a drought feedback loop can develop, which means the atmosphere dries out, the soil dries out the atmosphere, and you get this large area of high pressure. And it takes a significant pattern change to really beat it down and really bring the moisture in. So that's part of what we saw in the Southeast this past spring, where the drought grows so large that it developed this large area of high pressure that deflected the moisture to the north across the Midwest and then into parts of the Northeast. And what it will take to finally break that pattern is the El Nino subtropical jet stream to come in and bring multiple systems into the Southeast. And it's going to take months for them to get out of the drought. And there's a common expression in meteorology that most droughts end in flood, which is unfortunate, but it seems to be the case where, for example, in the Southeast, what typically ends a drought is a hurricane or tropical storm. And in the West, it's what's called an atmospheric river, which is basically a low pressure that develops way out in the Pacific and then brings a lot of moisture in as it trails from the Pacific, like Hawaii, into the parts of the Western U.S. and just dumps rain for a week and then replenishes what they've lost over the past, several months. So we'll have to watch for that weather whiplash, which is becoming more common.
Yeah, we talk a lot in meteorology when there's a drought. We always say the drought breeds drought, and it's simply because, as Chad was talking about, it gets increasingly more difficult to get out of it, especially during the summer months. And in a place like the Southeast, which is so dependent on tropical moisture and thunderstorm development, when there's less moisture in the ground, that can lead to there being less moisture in the air. It's still humid, of course, but it's not as moisture laden as it usually is. So that can make it more difficult to squeeze rain out of the thunderstorms that do develop, and that can help ease the drought. So as Chad was talking about, you almost need something bigger, a larger scale feature like a tropical system to kind of break that cycle and get some more moisture into the ground.
So interesting.
Yeah. I'm sure there's a lot of people that don't want to hear this. They want you to just say it's going to rain soon.
I don't know. I think our readers are pretty excited about following these weather patterns for whatever reason, definitely growers, but also just this idea of what we're seeing over time. Weather does affect all of us, and it's also not completely perfect to forecast it, as we also know.
That's right.
It's been very informative.
Yeah.
So I think we'd love to have you back on some other time, but I think this has been a great first podcast for us. Good.
Thank you.
Thank you.
June. This is the month for the bees, the heavy, sweet month, with much of the promise and the failure of the crop year in it. Discount your apple blossoms in late May or June unless the weather is right for the bees to pollinate. Damp and stormy weather may quarter your possible crop. Now is the time for good weeding in the gardens. Weeds pull more easily after a rain, but get them out of the garden fast. They root if piled or scattered between rows. Weeds hoed in the hot sun will be killed. Thin your garden stuff now. You will get twice the yield if you do. Start that compost heap. See your finished heap not more than 6 feet long and 4 feet wide. Start the bottom layer with coarse, long-fibered matter such as pokeweed, well cut up, or later on, corn stalks. On this generous layer, put good fresh manure of any kind to the depth of 3 or 4 inches. Then pile on lawn cuttings and any disease-free vegetable cuttings, no weeds. Sprinkle with agricultural lime, bone meal, or commercial fertilizer. Repeat the process with layers as described. The heap should not be over 5 feet high, with a concave center to catch and hold moisture. Heap should be ready to use for fall. That apt advice comes from the Farmer's Calendar in the Old Farmer's Almanac in June of 1944. Thank you for joining us for our podcast on weather wisdom. As our nation turns 250 years old, what can we learn from Revolutionary Era farmers? We invite you to join us for a future podcast featuring a lively conversation with former managing editor of the Almanac, Susan Peary, and John Fortee of Bedrock Gardens, or also known as the Heirloom Gardener, who tell us how and why to garden like it's 1776. Also in July, join us for a conversation with Pulitzer Prize-winning author Patrick Dillon. He's going to be writing the forthcoming history book about the Almanac called Tomorrow's Weather, Anybody's Guess, the centuries-old saga of the Old Farmer's Almanac.